Hi everyone, this is Dr. G. Ravindranath working as Assistant Professor in MLR Institute of Technology, Hyderabad. So we are discussing numerical methods and integral transform course. In that course, we are in the root finding techniques. In the root finding techniques, in this video, we are discussing Newton-Raphson method. So in this video, we will see the procedure of Newton-Raphson method and we will explain this procedure by taking some examples on the Newton-Raphson method. Now, so this Newton-Raphson method is a powerful method when you compare with the previous methods what we have discussed. So whatever the value, whatever the root we get for the equation by using this Newton-Raphson is more accurate than compared to the remaining methods here. So this method is also improves the result obtained by the previous method. So whenever we want to apply this Newton-Raphson method, like previous methods, no need to consider the two real numbers here. So we will consider only one real number, that is x0, as the approximate root for the equation f of x is equal to 0. For this equation, our task is for this equation by using Newton-Raphson method, we are going to find out the root of this equation here. Now let us see how this first approximation by Newton-Raphson method is given. So this is our standard formula to find out the first approximation using Newton-Raphson method. In this, we want a function f of x and its derivative. So by using function and its derivative, if you substitute these values in this formula, then we can get our first approximation using Newton-Raphson method. So like this, by replacing, suppose if you want to get the x2 value here, second approximation, just replace x0 with x1. So you will get x1 minus f of x1 by f dash of x1. So this is our standard formula to find out the second approximation using Newton-Raphson method. So similarly, if you find out the third approximation, replace x1 with x2. So x2 minus f of x2 by f dash of x2. So like this, we can find out second approximation, third approximation, fourth approximation, and so on, n plus 1th approximations. Now we will take the general form of this n plus 1th approximation here. So this is our standard formula. X suffix I plus 1 is equal to x suffix I minus f of x suffix I by f dash of x suffix I. So here I takes the values 0, 1, 2, 3 and so on. Suppose if you substitute, if you take I is equal to 0 here, you will get x1 is equal to x0 minus f of x0 by f dash of x0. You will get the same here. And if you take n is equal to 1, you will get this value. When we take I equal to 2, you will get x3 is equal to this value. So from this, we got this, we can consider the general form of Newton-Raphson method. So this we can call it as a Newton-Raphson formula. So by using this Newton-Raphson formula, we are going to get the root of that equation, and whatever the root we get by using this Newton-Raphson method, that is more accurate than compared to the remaining methods. So now let us take some examples on the Newton-Raphson method. This is our problem. So find by Newton's method or Newton-Raphson method the real root of the equation x into e power x minus 2 is equal to 0, and we can correct it to 3 decimals. So this is our equation he has given. For this equation, by using this Newton-Raphson method, we have to find out the root of that equation here. So compare this equation with f of x is equal to 0. So you will get f of x, compare this LHS part here. In place of f of x, you are having x into e power x minus 2. So I have taken that x into e power x minus 2 as f of x value. You consider this as equation 1. Now immediately you find out the two problem. Here x naught is not given in the problem, that is initial approximation is not mentioned. So whenever initial approximation is not mentioned in the Newton-Raphson method, so in some problems they will mention x0 value in the problem, like whatever the root we are going to discuss, going to find out that root lies near to some value, x is equal to something. So whenever we get this type of condition in the problem, then we can consider this 2 as x0 value as the initial approximation. But whereas in this problem he has not mentioned that initial approximation. So now if you want to get this initial approximation, so we have to go to the old procedure, that is we have to get two real numbers x0 and we have to get two real numbers. If you substitute the two real numbers in that function, we have to get opposite signs. We should not forget this basic point here. So I have taken two real numbers, x is equal to 0. So f of 0, if you substitute x is equal to 0, we got a negative sign, and immediately take x is equal to 1, we got a f of 1 is equal to positive sign. So you consider this as one value and this as another value. Now, but we don't want two real numbers for the Newton-Raphson method. So in order to get our initial approximation with the help of these two real numbers, take the average of these two real numbers here. 0 plus 1 by 2, we can consider 0.5, or we can take, this is one procedure to consider x0 value, or if you want we can consider this 0 as x0, or if you want we can consider x0 is equal to 1. We can consider any one of these two real numbers as x0 value, or the third option is we can consider the average of these two real numbers as x0 value. We can follow any one of these three. So here, so the root lies between 0 and 1. So here it is near to 1. So here in this problem, yes, we have taken as x0 is equal to 1. No problem. We can consider x0 is equal to 0, or we can consider x0 is equal to 0.5, or we can take x0 is equal to 1. So I have taken x0 is equal to 1, and now whenever we want to apply this Newton-Raphson, we want function, along with this function we want the derivative here. So now we'll find out the derivative of this. So x into, so d by dx of x into e power x minus 2. So exponential function is one function and this is an algebraic. So you apply a derivative of uv. So you will get this value, and the derivative of constant is 0. So we can conclude f dash of x is equal to x into e power x plus e power x. Now since we have taken as x0 is equal to 1 here, you substitute that value in the function. F dash of 1 is equal to e plus e. So you will get 5.4366. Now we got f dash of 1. Here we got f of 1. Now we have considered as x0 is equal to, now x0 is equal to 1. Now we are ready to find out the first approximation using this Newton-Raphson method. So by using this Newton-Raphson method, so already this is our Newton-Raphson formula, general formula. Now I want to get the value of x1 here. So put I is equal to, so put I is equal to 0. Then we can get our x1 value here. So the first approximation, after substituting I is equal to 0, you will get our first approximation, x0 minus f of x0 by f dash of x0. So replace x0 value, that is 1, f of x0, that means f of 1 value, and f dash of 1. You substitute this and simplify. If we simplify this, you will get our x1 value here. So we can consider x1 is equal to 0.8679. So once immediately after finding this x1 value, you substitute that x1 value in the function and get the value of f of x1. So f of x1, so f of x1 is equal to, this is our function, x into e power x minus 2. This is f of x value, and now we got f dash of x is equal to, we got this value as x into e power x plus e power x. So in the previous slide we got this. So this is f dash of x and this is f of x values. F of x1, f dash of x1, we got this. Now we are ready to go for the second approximation. So in the second approximation, if you want to get the second approximation, in the general equation you take I is equal to 1. So you will get x2 is equal to x1 minus f of x1 by f dash of x1. Now substitute x1 is equal to this value, f of x1 is equal to this, and f dash of x is equal to this in this formula. So you will get our, by replacing its values, if we simplify this, we will get 0.8528. So you consider this one as x2 value here. So now if you want to stop the problem, you compare this x2 with the previous approximation. So in the previous approximation we got 0.8679. Here we got 0.8528. So here after the decimal point, only the first digit is coincident. The second digit is not coincident. So we have to move for the third approximation here. So before going to move the third approximation, once again find out the value of f of x2 and f dash of x2 here. So f of x2 is this value and f dash of x2 is equal to this value here. So after finding this f of x2 and f dash of x2, then we are ready to go for the third approximation here. So after finding its function values, then we can go for the third approximation. So the third approximation, so from the general formula, if you substitute I is equal to 2, you will get our third approximation. So this is our third approximation values. In the previous step we got, in the previous slide we got x2 value, f of x2 value and f dash of x2 value. You substitute these values in the formula and simplify this, you will get x3 is equal to 0.8526. Okay. So in the previous approximation we got x2 is equal to 0.8528. So here we got 0.2526. So 3 decimals are coincident. So you go for the next approximation here. So we will get f of x3 and f dash of x3 values. Now we will go for the fourth approximation. So put I is equal to 3 in the general formula. We will get x4 is equal to x3 minus f of x3 by f dash of x3. Now you substitute all these values here. So you will get x4 is equal to 0.8526. In the present approximation, in the previous approximation, the x values are exactly same. So then we can stop and we can conclude that x3 is equal to x4. So therefore, the required root x is equal to 0.8526 is the required root for the given equation. So here in the Newton-Raphson method, the coincidence of x values, when we compare the present and the previous approximations, it will coincide very quickly here. That is the main advantage of this Newton-Raphson method. Whereas in the bijection method or regular falsy method, we have to go for the number of approximations in order to coincidence present approximation and previous approximation values. So this is the way how we can apply this Newton-Raphson method to find out the root of this equation here. Now let us take one more problem which is very important here. So now by using this Newton-Raphson method, we are going to derive some important formulas. That is how to find out the square root of a number, how to find out the formula, how to derive the formula to find out the cube root, and similarly how to derive the formula to find out the reciprocal of a number. Now let us discuss this. So once in general we will take a square root, how to derive the formula to find out the square root of a number. We can follow the same procedure and we can find out the cube root of a number or fourth root of a given number here. So first we will take this. So now I will concentrate how to find out the square root of this number here. So this number, I don't know the number. In the problem he has not given the number. So general I will consider this number as n. And the square root, we are going to find out the square root of this number. We don't know that square root of that particular number here. So for this purpose, I will consider that square root of that number as x. Now remove this square root here. and apply. In order to remove this square root, we have to apply the squaring on both sides here. So you will get x square is equal to n. So now convert this in the equation. X square minus n is equal to 0. Now, so why you are taking this one? Whenever we want to apply this Newton-Raphson method, that Newton-Raphson method is useful to find out the square, to find out the root of that equation. So before applying this Newton-Raphson, we want some equation here. So because of this, we have considered this root square root of n is equal to x. From this we got an equation. So from this we got f of x is equal to x square minus n. So where n is a number for which you are going to find out the square root. Suppose if you get a cube root here, so we can take, we don't know the cube root of that number, so we can consider that cube root n is equal to x. Now remove this cube root here. When if you want to remove this cube root, you have to apply cubing on both sides. So you will get x cube minus n is equal to 0. So this is the equation you will get whenever we want to find out the cube root. Okay, so no need to worry about this. So first we concentrate on the square root of a number. Okay, now this is our f of x, x square minus n. Now find out the derivative here. N is a constant, that is a number. So derivative of that number is constant. Since it is a constant, you will get derivative of n is equal to 0. So you will get only f dash of x is equal to 2x. Now we are having f of x, we are having f dash of x. Now we are ready to find out, apply this Newton-Raphson method here. So by using Newton-Raphson technique, so this is our formula to find out the Newton-Raphson. To apply this general formula, x suffix I plus 1 is equal to xi minus f of xi by f dash of xi. Now here I want to, we got this f of x value, f of x is equal to x square minus n, and f dash of x is equal to, we got this value is equal to 2x. Now from this I want to get the value of f of xi. So from this we will get f of xi. So just replace x with x suffix I, you will get x suffix I square minus n, and from this f dash of x get the f dash of x suffix I. So you will get 2x suffix I. Now replace these values and then simplify here. So you will get, so take the LCM here. So you will get LCM is 2x suffix I. So you will get 2x suffix I square minus of x suffix I square minus n. Now if you simplify this, if you remove these brackets here, you will get 2x suffix I square minus x suffix I square, minus of minus you will get plus n by 2 into x suffix I. So 2x suffix I square minus 2x suffix I square, you will get x suffix I square plus n by 2x suffix I. So by taking this here, you can, now this is of the form a plus b by c. So this can be written as x suffix I square by x 2x suffix I plus n by 2x suffix I. So one x suffix I gets cancelled here, you will get x suffix I by 2 plus n by 2 into x suffix I. Take 2 common here, you will get this. So this is our standard formula to find out the square root of a number by using Newton-Raphson method. Now in this, suppose if you want to find out the square root of 28, put n is equal to 28 in this formula, then find out xi values and xi values here, then we can get our required square root of 28 here. So this is how to find out the square root. Similarly, we can go for the cube root, fourth root and so on by using this. Now in the second, we will go for how to find out the reciprocal of a number here. So the reciprocal of a number here, I will consider that reciprocal of this n, 1 by n is equal to x. So from this you will get an equation of the form f of x is equal to 1 by x minus n is equal to 0, and here Similarly, n is a number for which you are going to find out the reciprocal. Okay, from this, if we compare this with the standard form f of x is equal to 0, you will get f of x is equal to 1 by x minus n, and find out the derivative. F dash of x is equal to minus 1 by x square. Now here we are ready to find out that apply this Newton-Raphson method. So this is, we have the standard formula, x suffix I plus 1 is equal to x suffix I minus f of x suffix I by f dash of x suffix I. So here f suffix I, this is our f of x value, replace x with x suffix I minus n. F dash of x, we got this minus 1 by x square, replace x with x suffix I, and simplify this, you will get our required formula here. So this is the way how we can apply this Newton-Raphson method. So in this video, we have discussed the procedure of Newton-Raphson method, and we have taken some examples how to use this Newton-Raphson method to find out the root of the given equation. So in the next video, we will go for the next root finding technique, that is iteration method. So in that, we will take the procedure what is the procedure for iteration method, and how to find out that roots for the given equation by using iteration method. Thank you all.